Machine learning is a powerful type of artificial intelligence. It allows computers to learn from data. Computers can then improve their performance on a specific task. Think of it like teaching a computer to learn from experience, just like humans do. Machine learning is incredibly important today. It's used everywhere. It powers our favorite apps, helps businesses make smarter decisions, and even diagnoses diseases. Machine learning is changing the world as we know it. It helps us solve complex problems in ways we never thought possible. From personalized medicine to self-driving cars, machine learning is revolutionizing industries. In traditional programming, we write explicit rules for the computer to follow. We give it data and a set of instructions to process it. For example, if we want to program a calculator, we tell it exactly how to add, subtract, multiply, and divide. Machine learning flips this paradigm. Instead of programming explicit rules, we feed the computer data and let it learn the rules on its own. We provide it with examples, and it figures out the patterns and relationships in the data. Imagine trying to teach a computer to recognize cats in pictures. With traditional programming, we'd have to write code to identify whiskers, ears, tail, and other cat features. Machine learning simplifies this process. We show the computer thousands of cat pictures and it learns to identify them on its own. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Each of these types has unique characteristics and applications, making them suitable for different kinds of tasks and challenges in the world of data science and artificial intelligence. In supervised learning, we provide the computer with labeled data. This means that each data point is tagged with the correct answer, allowing the algorithm to learn from examples. This means each data point is tagged with the correct answer. The algorithm uses this information to make predictions or decisions based on new, unseen data. Imagine a spreadsheet where each row represents a house, and the columns include features like square footage, number of bedrooms, and location. These features help the algorithm understand the different aspects that might influence the outcome. The last column is the price of the house. By analyzing this labeled data, the machine learning model can learn the relationship between the features and the price. This labeled data helps the machine learning algorithm learn the relationship between the features and the price, allowing it to predict the price of new houses. Supervised learning is widely used in applications like email filtering, fraud detection, and even medical diagnosis. Unsupervised learning is like exploring a new city without a map. Here, the computer is given unlabeled data and must find patterns and structures on its own. We give the computer unlabeled data and let it discover patterns and structures on its own. This type of learning is useful for tasks like clustering, where the goal is to group similar data points together. Think of a data set of customer purchase history. An unsupervised learning algorithm can identify groups of customers with similar buying habits. An unsupervised learning algorithm can identify groups of customers with similar buying habits, helping businesses target their marketing campaigns more effectively. It can also be used for anomaly detection, where the goal is to identify unusual data points that might indicate fraud or errors. Reinforcement learning is like training a dog with rewards and punishments. In this type of learning, the computer interacts with an environment and learns from its actions. We let the computer interact with an environment and learn from its actions. If it takes a good action, it receives a reward, encouraging it to repeat that behavior. If it takes a good action, it receives a reward. Conversely, if it makes a mistake, it gets penalized, discouraging it from repeating that action. If it makes a mistake, it gets penalized. This trial and error approach helps the algorithm learn the best strategies to achieve its goals. This type of learning is used in robotics, where robots learn to perform tasks by trial and error. It's also used in game playing, where AI agents learn to master complex games by playing them repeatedly. Each type of machine learning has its strengths and is suited for different types of problems. Understanding these differences is crucial for selecting the right approach for a given task, ultimately leading to more effective and efficient solutions. Data is the fuel of machine learning. Without data, machine learning algorithms would have nothing to learn from. It's the raw material that powers the entire process. The more data we have, the better the machine learning model can learn. Large data sets help in capturing the underlying patterns more effectively, leading to more accurate predictions. Data can be anything: text, images, videos, audio files, and even more complex forms like 3D models or sensor data. Sensor readings, for instance, are crucial in fields like environmental monitoring and healthcare, providing real-time data for analysis. The model is the heart of machine learning. It's essentially a mathematical representation of the problem we are trying to solve. It represents the algorithm and the learned patterns from the data. These patterns help the model make predictions or decisions based on new data. Think of it as a mathematical function that takes input data and produces an output or prediction. This function is fine-tuned during the training process. Training is the process of teaching the model to make accurate predictions. This involves feeding the model with a large amount of training data. We feed the model with training data and adjust its parameters until it achieves good performance. This iterative process is crucial for the model to learn effectively. Testing is how we evaluate the performance of the trained model. It helps us understand how well the model generalizes to new unseen data. We use a separate dataset that the model hasn't seen before and measure how well it makes predictions on this unseen data. This step is crucial for validating the model's accuracy and reliability. These components are essential for building and deploying successful machine learning systems. Each part plays a critical role in ensuring the model performs well in real-world applications. Section 5. The machine learning process. The machine learning process involves several steps, each critical to building a successful model. First, we need to collect and prepare the data. This involves gathering data from various sources, which could include databases, online repositories, or even real-time data streams. This step is crucial, as the quality of the data directly impacts the performance of the model. Poor quality data can lead to inaccurate predictions and unreliable results. Data pre-processing involves cleaning the data, handling missing values, and removing any inconsistencies. This ensures that the data is in a usable state. Additionally, transforming the data into a format suitable for machine learning algorithms is essential. This might include normalizing values, encoding categorical variables, or scaling features. Next, we select the right machine learning algorithm for the task. This decision is based on the problem we're trying to solve, whether it's classification, regression, clustering, or another type. This choice depends on the type of problem, the nature of the data, and the desired outcome. Different algorithms have different strengths and weaknesses. The nature of the data, such as its size, dimensionality, and distribution, also plays a significant role in this selection process. Once we have the data and the algorithm, we train the model. This involves using the training data to teach the algorithm to recognize patterns and make predictions. This step involves feeding the training data to the algorithm and adjusting its parameters to minimize errors. The goal is to find the optimal settings that yield the best performance. Fine-tuning these parameters is often an iterative process, requiring multiple rounds of training and validation. Finally, we evaluate the model's performance on the test data. This step helps us understand how well the model generalizes to unseen data and its potential real-world performance. This step helps us understand how well the model generalizes to unseen data and identify areas for improvement. Performance metrics such as accuracy, precision, recall, and F1 score are often used. Identifying areas for improvement allows us to make necessary adjustments and enhancements to the model. This iterative process allows us to refine the model and improve its accuracy. Continuous evaluation and tuning are key to maintaining a high-performing machine learning model. Section 6. Real-world applications of machine learning. Machine learning is everywhere. It powers voice assistants like Siri and Alexa, enabling them to understand and respond to our commands. Self-driving cars rely heavily on machine learning algorithms to perceive their surroundings, make decisions, and navigate safely. In banking, machine learning helps detect fraudulent transactions by analyzing patterns and identifying anomalies. Recommendation systems used by companies like Netflix and Amazon leverage machine learning to suggest products or movies that you might like based on your past behavior and preferences. These are just a few examples of how machine learning is transforming various industries. Section 7. ethical considerations and challenges in machine learning. While machine learning offers immense potential, it also presents ethical considerations and challenges. One concern is data bias. If the training data reflects existing biases in society, the model might perpetuate these biases in its predictions. Privacy is another important concern. Machine learning models often require access to vast amounts of personal data, raising concerns about data security and privacy violations. Model interpretability is crucial, especially in sensitive domains like healthcare and finance. It's important to understand how the model arrives at its predictions to ensure fairness and accountability. Addressing these challenges is crucial for building responsible and trustworthy machine learning systems. Section 8. The future of machine learning. Machine learning is a rapidly evolving field. Deep learning, a subfield of machine learning that uses artificial neural networks with multiple layers, is pushing the boundaries of what's possible. As AI and machine learning become more sophisticated, they will likely have a significant impact on the job market. Some jobs may become automated, while new jobs will emerge in fields related to AI development and deployment. The future of machine learning is bright, with the potential to solve some of the world's most pressing problems. And Section 9. Getting started with machine learning. If you're interested in learning more about machine learning, there are many resources available. Online courses like those offered by Coursera and Udacity provide a comprehensive introduction to the field. Python is a popular programming language for machine learning, and libraries like TensorFlow and scikit-learn offer powerful tools for building and deploying machine learning models. Don't be afraid to dive in and start experimenting. The best way to learn machine learning is by doing.